one. All right. Yeah, we're getting up to halfway. So let's go ahead and get started. We're starting on one of the best parts of Linux today, which is pipes and redirection. This is a facility that is built into the operating system, and it's a huge benefit to us because, one, it makes our life easier. That's the first one. Second one is it allows us to do some interesting and fun things. All right. By using the shortcuts and the techniques that we talk about today, all right, we're going to talk about the ones that we can use to make these colors on the screen, all right, make a little bit of fancier sorts of interfaces and, generally make things more interesting. And also we'll look at ways to make our life easier, all right, when we're, for example, what we'll do next week is when we are creating and testing our firewall rules, for example. Right? Firewall rules only get stored in memory until we save them to a file, but there's a lot of typing in there, and it's very easy to get your fingers crossed up and make one little mistake that blows everything. So we can, if we know our shortcuts, becomes very straightforward to create our firewall rules, test them, and immediately save them so that we never have to type it again. And that is about making our life easier because it's meant all of this debugging and these little typing mistakes can give you too many gray hairs or tear your hair out, bald spots like that. It's meant. So that's what we're going to be talking about today. It relates to several of our enhancements on the assignment because it seems a little bit abstract, but it's just a very basic technique that we need to know about. We need to understand how useful it is and the ways we can take advantage of it. So I'm going to turn off the camera here. Let's start with a little bit of theory to guide our practice, all right? Getting to know a little bit about what we're talking about in terms of a topic of pipes and redirection, all right? This is the one that's labeled 08 in the lecture notes, all right? Now, I just got one more thing here. It's called shell, all right? Now, the shell is the command line interface to the operating system, all right? And it's running in the background when we start our VMs here. Let me just do this. I'm going to pull this up to be big. There we go. All right. The prompt right here is put up by the shell. It's a process that the operating system on our virtual machines starts automatically. On Windows, I just showed you, we've got Windows PowerShell, all right? And PowerShell in Windows is exactly the same as the shell we use in Linux. All right. Now, there's a few different kinds of shells in Linux. All right. Windows has two. One is called Command, and the other one is called PowerShell. All right. And the difference between them is that PowerShell has a lot more scripting capabilities. All right. Let's just make a note of that one as well. All right. In Windows, we have PowerShell and Command. PowerShell scripts are more powerful. Guess what? I think they're called PSH, like the push flag in TCP. Command is more classic, and script files are called .bat, because back before the days of Windows, when Bill Gates invented his MS-DOS operating system, he called the scripts batch files because there'd be a batch of operating system commands that were included in a single file. And just like the browser interprets JavaScript and CSS, the operating system, Shell will read that file and take every line as a command, the exact same command we would enter at the command line. All right, so when we talk about shell scripting, we're talking about saving commands that we enter at the command line to a file so we can execute the same commands over and over again without ever typing them again. Got an itch this morning. So that's where we're at here. All right. Pipes and redirection are a little bit more abstract, but they make things a lot more fun, all right, because it makes it very easy to make shell scripts and do interesting things with them. All right. Oh, shells, pipes, and redirection. Here we go. All right. Now, there are as you can see here, all right, these tricks and techniques that we're talking about today, there are a number of places on the TinyNet site that they are described, all right? And again, that may sound a little bit complicated, but it's because you try and keep the pieces short. But there are a lot of examples for us, examples in practice. And we'll take a look at how this relates to the exact enhancements on the assignment a little bit later, okay? But let's get the overview here let's get the overview now. So this should be familiar. All right. Process is the basic unit of activity for the operating system. And one of the things way back in the 1960s, early 1970s, in operating systems was the idea of using the file as an abstraction, right? So this was revolutionary at the time. Memory is a file, the keyboard is a file, the screen is a file, all right? And each one has particular characteristics that are handled by the device driver, right? But a layer above that, everything is treated as a file. When you get that fundamental concept, it takes a little bit to wrap your mind around it, but that's what makes all of this possible. All right? File is an object that a process can read from or write to. The process just sees everything consistently, and the device drivers and the lower layers of the operating system take care of channeling that to the proper destination. There's a concept that we haven't, I think, encountered, but again, this is exactly the same in Windows. This concept of an environment and environment variables, all right? Environment variables just are ways to pass things between processes, all right? And again, the operating system, the shell actually, the shell keeps track of the values of the variables that we assign. And it's very useful in shell scripting because that means we can set a variable and use it several times in our commands, right? Or we can actually read a value of a variable from the command line and use that in our shell scripts. And those are the kind of techniques that we want to investigate today. So here's where we get a little bit abstract, all right? Now, this is the place where we're at the interface between the operating system kernel and our usual comfortable user space, all right? But we need to understand this idea of file descriptors, all right? Now, we're accustomed to the idea of a UID, a user ID is just a number, and the username is the one for people, but it always maps to a user ID. Same thing for a GID, a group ID. Same thing for an IP address, right? Same thing for a file, right? When I double click on PowerPoint in Windows, Windows is going to open a file descriptor, which is a numeric representation that the operating system can use so that when I switch windows or when I want to save this file, it can keep track of the destination. Okay? But hidden in the background at the shell level, there are 3 standard file descriptors. And again, standard since, 1974 or something like that. File descriptor 1 is called standard in. Sorry. 0 is standard in. 1 is standard output. And 2 is standard error. Now, this 1 and 2 is, in practice, a bit frustrating. because with our command line tools, you never quite know if the programmer is sending the output we see to standard out or standard error, right? But there's a way we can get around that. And again, that's going to look better in practice than it is in theory. But let's just keep that point in mind and we'll get back to it. All right. So by default, when we work at the command line, the shell expects to be reading standard in for its input, and that means that standard in is directed to the keyboard, or it's assigned to the keyboard. Right? Normal output, standard out, and error messages, both are assigned to the terminal. The idea here is that if we wanted to put the error messages in a different place, we could, right? So that we don't see the error messages at the same time and place that we see the normal output from our command. But when we're just looking at the output of a command on the screen, we don't know which of these output channels we're looking at. But given all of that, these abstractions make it easy and fun for us to set up connections between these file descriptors. And that's one of the great conveniences that we have available, and learning how to take advantage of it is fundamental to improving our efficiency and making our life easier as systems administrators. So here's one that's called the pipe, right? Yep, 2-pointer dev null. Good on you, you got it. All right, we're going to get there in just a minute. All right. Most commonly used character is pipe that chains together the standard output of one process, chains that up to the standard input of the next process on the line. All right? This is what we call redirection, right? Because this chain lasts only as long as these two processes. It's not permanent, all right? But technically it's redirecting the standard out of the first process and pointing it to the standard in of the second process. And that is what our friend has suggested here. All right, I'll just add one to that. 2 got the wrong key here. Just to make sure that we don't forget to come back to that one. All right, so let's shift over here. All right, let me just pull up my machine here. Let's pull this down. What happened here? All right, let me just log in here first. All right, so let's clear this away. and say, all right, so this is too big. It scrolled off the screen. All right. But here's the first trick. First trick. Here to clear the screen. All right. If I want my previous command back, you just touch up arrow. I think we knew that already. All right. Now, what I'm going to do is I'm going to pipe this into a command called less. And what less does is allows us to see it on the screen, but we can use the arrow keys to move up and down the list. All right, so now I can move down, I can move up, and I can see what's there. Notice it's all in one column, all right? And it's not nice colors like we had before, all right? But that's because our color codes don't get passed through the pipe. I'm just going to cue to quit with less up here. There we go. All right. So again, these color codes, we're coming to that really, really soon here. All right. But this is an operating system that setting that we can modify if we can poke up through the configuration files and find our way around there. All right. So, but this one took the output and sent it to more. More is an alternative. More is the old one. You can't move up in more, you can only move down. And so when somebody decided to improve it, they called it, guess what? Less. I don't know, never mind. The other characters that we use for redirection are what I call reverse pointy, and then pointy, and double pointy. Okay? You can call them what you like, but that's kind of my dialect for it. All right? So redirecting standard out to a file is very common. All right? And this is a hugely useful thing for making shell scripts, because we can get a command on the command line, and once we test it out, once we know that it works, we can just up arrow it, wrap it up a little bit, and send it to a file so that it's going to be there for us forever. Right? As long as that file is there, we're going to have these commands so that we never have to type them again. All right, let's try that one out. I got a fun one here. That. Hang on. You guys should leave the magnifier up and that down. But all right, let's clear this away. Get my keys confused. Here we are. It's not going to work. Okay. Hang on 1 second. It's Kali Linux. That's not what we're about. Let's roll this one up in the browser a little bit. And fix the menu with a reload. There we go. Okay, down here in standard I/O. All right, this is where we're at today. All right, there's a page here on redirection. This page on redirection is a bit more complete than the one that we've looked at. It starts off the same way, pipes and redirects. All right. And there's dev null and a few more examples. And then it goes into some more advanced ones called named pipes. All right? And named pipes are used in the multi-tail enhancement on the assignment, okay, and in a couple of other places. Right? But I'm going to leave that one. But these pipes and redirection, the basic pipes and redirection, are something that is very good for us to experiment with, especially when we're using ASCII art. And I'll open this one on this page. Script input and output. All right. This one has some technicalities about Bash scripting. Now, while I say that, let me just point out real quick here. Bash scripting is probably third on my list of least favorite programming languages. Perl. Perl and PHP are right up there at the top, along with Bash and Awk. I don't know which one is worse. Awk is definitely worse than Bash. Bash has a lot of syntax variations, all right? And that is just to accommodate a lot of different people's preferences and trying to make it as, flexible as possible. But as always, great flexibility means great complexity, right? So there's always two ways, most of the time, three ways to do things in Bash. And, it's meant the best way to do it is to try to understand the simple things and work from examples, okay? Because there's so much out there. It is usually not too much of a problem to find a script that does approximately what you want to do, right? And then you can just modify that a little bit to meet your needs exactly. But on this page is the one Script.io, right? That has a quick reference on the date command, right? Which is it's easy enough one for us to do some tests and demonstrations, right? And it's got a script here, all right? We've got a copy of it, so we don't have to copy it off the website, but it's here for complete documentation that shows us some of the tricks that we can use to pass input, all right, to a shell script. But let's work our way up to that a little bit, all right? We've also here on the ASCII art page, there's a little bit of fun. All right. ASCII art is using normal characters to make designs. All right. We've got two that we can use for this. One's called Figlet, and the other one is called Boxes. Right? And by piping these together, right, then we can make some really nice effects, right, and jazz up our screens a bit to make them look much more interesting. Right? So there's just some documentation here about the most common switches. Right? We also have a fortune generator. Okay, sometimes they call it fortune cookie. Right? That can pull up a random fortune from its database. Right? And that's part of one of the enhancements on the assignment as well. So let's just experiment with some of this stuff a little bit, right? See how it works. All right, now what I need to do, I think I want to have this. I want to have this one handy so I can refer to it. Let's see if I can size this up properly. There we go. All right, okay. So let's just walk through this a little bit. The first thing is the variable assignment. All right. Now, again, I can write this into a file. I can type it into a file automatically, or I can do it at the command line here and then wrap it up a little bit. So let's start off by setting a variable dd equals hi there. All right. Now, if I want to just print that the value, print the value of that variable to standard out, all right, I say echo, then I put a megabucks sign in front of the variable, and dash sends the output of that variable to standard out. Got to do that at dd, right? Okay, now here's a good trick, all right, that's described over here. I can also save the output of a command to a variable. All right. So I can do plus % little x plus % big X. Let's see if that works. I say date. All right. And then I do plus, I don't know if I need space there or not. Never mind. % little x plus %. Maybe I. Oops, extra operand. Let's try this. Yes, it is. Percent little x. Oh, it's little x. dx. That looks horrible. No, but look, there we are. All right. Let's put a space in the middle there. Oops. Can't do that. There we go. All right. Now, what I just demonstrated here, all right, is that when we want to pass parameters to a command like date, all right, and we have a space in the middle, we have to wrap it up in quotes, all right? We don't wrap it up in quotes, we get the error extra operand, all right? And if we pass it all as one, we don't get the space that we wanted. Up here. All right, we'll talk about the quotes a little bit more in just a minute. Let's try this though. I want to save this to a environment variable. All right. To do that, this time I say dd equals, all right, and I wrap this up. Put a buck sign here and wrap this up, the whole thing, wrap it up in quotes. All right. Nothing happens there, but now what happens when I do echo? I've got the new command line string that I wanted because I saved the output to that variable rather than just saving a string. All right? Let's clear that away for a minute. All right. Now, let's extend this one more time. All right. Let's do this. Let's say echo. They, let's say now. Now it is, no it is, now it is. All right. Now, notice there I used single quotes. Okay. And again, if I didn't put any quotes there, the operating system would just take now and it would take all of those as separate parts. But if I enclose them in quotes, okay, then it takes it all as one. But there's a difference between single quotes and double quotes. So I use single quotes, right? Everything on that line is preserved exactly. All right? So single quotes make everything preserved absolutely exactly. All right? Double quotes tell the shell to interpret the string before it gets sent to standard out. So now it gives me the value of the variable. Right, so gotta be careful with that one, right? But again, knowing that difference and being able to take advantage of it is one of the things that makes our life easier. Escape characters. Single quotes preserve everything precisely as it is on the command line. Oops, wait a minute. Let me get back to my single quotes here. Yeah, everything. It's just taken as a static string and nothing is changed. Inside, it's a little bit different, but never mind, let's not get distracted. Let's not get distracted by this. It's just to say single quotes preserve everything exactly. And this echo with single quotes is something hugely important for us to understand. Okay? So let's play. Let's pick up this one and let's pipe it through boxes. This is our first ASCII art experiment. All right. So now it should take that. Now it is 11/11/2021 and send that output. Instead of sending that output to the screen directly like that, it's going to send it to our program boxes. And boxes draws a box around it. All right. And if I come back over here, just take a second here to boxes. Ooh, we got to pipe that through less so that we can page up and down. Boxes minus L. It's not a 1, a lowercase l. Boxes minus L. Let's pipe that into less so we can move around because there are a lot of designs. Box quotes. Oh boy. That's the common one here. Oh, there's a fun one. Cat girl. Cat. Oh, there we go. We use a design. I think it's boxes minus D. Just double check here. Oops. Double check here. The Z. There we go. So let me cue to quit this. Clear this away. Boxes. Oops. Boxes minus D. Cat. Hey, there we are. Ha. This is what makes ASCII art fun. ASCII art, I don't know, man. I mean, some people must have too much time on their hands because they spend all their time getting all of the spaces just right. But it is kind of fun to take advantage of it. There's another one I like that's called columns. Yeah, there we go. All right. So this is what ASCII art is about. And when we start putting this in color or showing it up in different ways, you know, right, it really can be kind of good. And again, the date is just one way to get some short output strings, okay, that we can use to test. Right, so I can use this one also with, instead of my variable here, I could say fortune. There we go. Parallel lines now out. Let's try that again. Why should one ever throw an egg to a cockatrice? Ouch, it's too early for that kind of a question. All right. There we are. The reliability of any machinery is inversely proportional to the number and significance of any persons watching it. Now, I don't really like that one because it ran off the screen. So, just going to point this out. There's a solution for that problem, all right, is to pipe it through another utility, all right? So I've got boxes minus D columns here, and what I'm going to do is put it through fold. All right? Fold is simply a utility to word wrap, all right, at the place that we specify. So if I say fold minus S to break at the spaces and minus W with the width. Oh, come back here. So useful when bored, Alan Schmidt. Don't talk that way in SNA class. Fortune, let's pipe that first. Fold minus S to fold on the spaces minus W. Let's make it 67. Oops, that's not going to work. Hey, that one's too short anyway. A day without sunshine is like, there we are. Okay. E55 divided by 113. Not the famous irrational number pi, but an incredible simulation. I got a calculator here, but I think it's probably better to, what time is it? 9:22 here. Let's come back. Let's take a little break. It's 9:31. Just to pick an odd time of the day for us. Let's just take a little break and come back in a few minutes. Okay. All right. So that's the first step. All right. We've got the pipes down. We understand a little bit about variables, understand a little bit about Bash syntax when it comes to quotes. All right. The echo command just says, send this to standard out. All right. And when standard out is pointed at the screen, then we can see it on the screen. But when we redirect the standard out, we can redirect it into another program, or we can redirect it into a file. And that's what we're going to do next, because that's a super important technique for us to know about. From there, we can work on making a shell script, all right? Understanding how to make a shell script so that we can just run this command anytime we want to. So let's start with that. Back to my gateway here. All right, there we are. Let's clear this away. But I've always got my last command just an arrow key away. All right. Now, let's not use fortune. Let's go back here for a minute. And let's say, what do we want here? Let's not use Caesar yet. Let's come back here. Oh, good. Let's try it this way. Percent big A, the full weekday name. All right, and percent big B is the full month name. What do we get? Oh, we just get the 24-hour time and minute. I don't see the, oh, I get the month. Oh, plus. That's an hour and a minute. Never mind. Let's do it this way. Let's do it this way. Let's do it this way. Let's say date plus quote. There we go. And we'll say plus percent. Syntax is really, really strange, but I didn't invent it, so, never mind. Percent big A, and then percent X, and then percent big X. Big A, and then percent little x, and then percent big X. Passing that all in as one thing, so we put it in quotes there. All right. And we've got boxes and columns already set up for us. There we are. All right. Let's this way. There was one character there that said new line, percent N. All right. Now let's see what happens. What should we do? Let's do this. Let's save this to a file. In order to do that, all right, what we need to do is we need to take that command and wrap it up in single quotes, all right? Because as we saw before, we need to keep those double quotes there for that command to execute properly, all right? And so we need to get that command back, and we'll wrap it up in double quote. I'm sorry, we wrap it up in single quotes, all right? So that when it comes out, all right, it's going to have exactly what's there. Then we'll put an echo in front of it. And we'll see that command exactly as it should be. And now what we do is we use a single pointy to save it as a new file, and we'll call that today. TTOODA is today. Right? No news is good news here. Right? But if I look inside my directory here, I've got, there it is, Tatuda, today. Right? So if I just say cat, TTOODA, right? I can see the command there. But that doesn't help me execute it. All right. What I need to do first is to make this a bash shell script. We need the magic abracadabra. Bash shell. That's more fun to say than it is to type. The way we pronounce this is hash bang stroke bin stroke bash. All right. This is a magic line that tells the shell to use this interpreter to start a sub-process, and all of the commands in this file get passed directly to that interpreter. All right? And then, okay, this must be the first line of the file, no leading white space. all right? That means it has to be the first line of the file, no spaces, no tabs, no blank lines, no nothing in front of it. So I'm going to, there's two ways we can do this. One is the MC way. Let's do it the MC way first, and then we can do it the command line way. So I'm going to start up MC here, and I'm going to F4 this one to edit. And just at the top here, I'll put hash bang stroke bin stroke dash dash. There we go. All right, and then I can F2 to save. Now, the other thing I need to do, F10 to exit, is I need to make this green star executable. We know how to do that, right? Need to do an F9 on file and chmod and set the execute bits. Now I'm going to exit MC, F10. Where's F10 on my keyboard here? There we go. And take a look at what's there. Now I can say / execute from the current directory, ttod 2D. Look at that. Let's see if it, there we go. Change it to seconds. We can see that it executes every time. All right. That is one way to make a shell script. The other way we can do it is just at the command line. All right, we can clear this away. Let's try this. There we go. All right. Hang on a second. Good on you. Good on you. This is the way we can have fun at the command line. Oops. Oh, I do want to do it that way. I'm going to come back here, and I'm going to come here, and I'm just going to make this one fortune, like we had before. All right. And I'm going to keep it wrapped up in single quotes. All right. And I'm going to pipe that one into FF. Make a new file called FF. Doesn't matter what it's called. All right. And enter. Right. So I've just got that one line there. Now what I'm going to do is the important step. I'm going to echo, and again, single quotes to make sure that this doesn't get messed up by the bash interpreter. I'm going to say hash bang stroke bin stroke bash. Right. I'm going to echo that into another file that I'm going to call MA for Magic Abracadabra. Right? Now what I'm going to do, even more fun, is I'm going to say get and then use a double pointy. Now, the difference between pointy and double pointy is that pointy creates a new file every time. If the file already exists, it gets overwritten. Double pointy adds it on to the end of the file. All right? In Bash, double pointy will create the file if it doesn't exist already, which is kind of convenient, but that's not standards compliant. That's just an extra Bash-ism. All right? Normally, we think that we only use double pointy according to the standard when the file already exists. So, by cat ff to ma, what's going to happen? Cat just reads the file, displays it on standard out, but standard out is pointing at the end of this file ma. So now, when I cat ma, I've got 2 lines. The last thing I need to do is set the execute bits, just like in MC, but we'll do it here on the command line, chmod, and set the permissions to 755. Yeah, now my MA is there, and I can just do ./MA. Yay. Oh. Recognize a mistake when you make it again. And I never have to type those commands again because I have them. Systems about which nothing general can be said except nothing general can be said. That's an arbitrary system. I never have to type it again because I've saved it to a shell script. I've made it executable. This is the thing that makes writing and testing our firewall rules like we'll do next week. This is what makes it smooth and easy, is to be able to create a shell script with just the magic abracadabra in it. All right. Then go on and type our firewall rule. All right. Then we test it. And once we're happy that it's working, we can save it to the shell script so we never have to type it again. It's always going to be there for us. Once we know what we want to do, we can just save it to a shell script, and it's there permanently for us. Appending, there we go. That's what we're doing. So, and again, if we want to combine these together, we can always just go in and edit our shell script. What did I have? There it is. TTOODA. All right, let's do this. Let's say F that to just to see what happens. Oh, look at that. Yeah, it works perfectly. We can. And again, we can just go in and edit that. If we want to change that columns to something else, then we could just go in and edit. And change that to a try that one from memory. And F2 to save, F10 to exit. F10. Oops, unknown design, ADA box. Ooh, ouch, man. What do you say, less? That's a cue quit. No, I get that messed up. Oh, one box is minus L. Ouch. Of course, B is the design. L. That's what. Oh, ADA minus box. Okay. Yeah. Never mind. Just takes a little bit of experimentation. But once it's in the shell script, it's there for us and our viewing pleasure. There we go. Don't walk too close to metal objects which are not fastened down. All right. So let's take this. There's 2 steps farther that we can go here, right? One step, easy step, fun step, is adding in colors for when it's displayed on the screen, okay? And the other step is reading parameters from the command line or from standard in as a pipe, right? Now, both of those are demonstrated in the script.io page here on the TinyNet site, right? The one that has the syntax and the date, right? And there is a script in user local bin, right? Hey, why does it say that twice? Ugh, okay. The script is already there, all right? Now, the one thing that's different from what we've just done, right, is that it uses this semicolon here to string commands together. Now, this is a command line convention, and normally we put this, let me go back. Do this. Just get the plain command here, right? And I'll say date, votes, and plus percent big. Where'd you go? Hey, come here a minute. Well, there it is. Plus percent big A. And now I'm just going to put a semicolon here. All right. Ouch. Control C. What did I do? I left that one on the end down there. I shouldn't have. All right. Now, what the semicolon does is the semicolon does is it just strings these two commands together. All right. So pipe like this, figlet, all right? Fillet, figlet. Pipe like between date and figlet, or between fortune and fold and boxes, all right? That strings those commands together with a relationship, all right? The output of fortune, standard out for fortune becomes the standard in for fold, the standard out for fold becomes the standard in for boxes, all right? But the date part before the semicolon and the fortune part after the semicolon have no relationship except that they're on the same command line. It doesn't stop and print the prompt in between. They're just two commands strung together. So, just to say, that's what Figlet does. Figlet just prints things in big letters. And there are, again, a few different Figlet fonts, all right, that you can take advantage of to change the appearance of that. Well, I'm not going to experiment with that right here, right? But let's, which one was the one that I had? Oh, I don't have one that just has the magic abracadabra anymore, but never mind. Okay, let's work with this one. All right, so first, let's try to put it in color. Now, the color thing is really hopelessly arcane and horrible, horrible thing to mess with, all right? But you get used to it, and it's got a really regular structure, so it's not that difficult to deal with. Oh, I know what I should do first. Now let's go for it. Here on the TinyNet site, you can find this all over the internet, but the easiest place to find it is actually right here in the quick reference list for escape codes. All right? Quick reference list for here for escape codes. Tick tock, tick tock, tick tock. Even TinyNet suffering from TikTok today. Let's let it sit for a minute. It wants to take a long time loading. We'll let it take a long time. Oh, there it is. All right. So here's the thing. All right. These are the color ones. All right. I tend to always use the bold ones, all right, because they look a little bit better on the screen. All right. So if I put in a 1 semicolon 33M in the right format, that's going to change all the text on the screen to bold yellow. And the right format is what we can see here in this shell script. All right? It's \E and then a square bracket. All right? And then again, once you get started, it gets easier because you can change the colors really quickly like this. This one down here changes the color back to the default. So let's try it out. I've got my command here. Let's put a -E so that it knows this is an escape code. E, then double quotes, and what was it? \square 00M. \square 00M. Then I just attach that one to change that color. And now I'll do it again. Echo -E, double quotes, semicolon. Now I can fill in the hard part here. \square. What's my number? 1 semicolon. Let's take yellow. 1 semicolon 33M. 1. Oops. Semicolon 33. Oh, right. Echo is not going to work. There we go. So now I've got 4 commands on the same command line. All right. I've got my echo to change the color, then the date for Figlet, then fortune, and fold it up inside a box to word wrap it, and then turn the screen back to its default for the prompt. Hey, what happened there? Ooh. I didn't catch the, oh, something went wrong with my, something's wrong. See what happened up there? I can see the code here. So something went wrong with my string here. Hang on a minute. Maybe I should. Yeah, it should have worked. Maybe it only works in a shell script. Need a 0 in front of that, but maybe I do. Oh, okay. It's not working at the command line properly. Ouch. Let's check. See if the documentation is right. Show parms.sh. Show fig fonts. I don't have it. Okay, now I don't have it because it's not there yet. I'm missing the E after the backslash. Oh, maybe you're right. I think you're right. I think my eyes are funny this morning. Thank you so much. You are absolutely correct. All right. That's what I forgot to do. Now, I can never remember. Oops, wait a minute. What color is cyan? Never mind. Let's try it out. The color is cyan. Oh, it's kind of like blue. There we are. Never make anything simple and efficient when a way can be found to make it complex and wonderful. This is absolutely contrary to the way we want to think. Okay. So that's putting in the color codes. And the other part is reading parameters from the command line. All right? And that's what this script does. But I just looked for it, checked for it in user local bin, and I couldn't find it. All right? And that brings us to an important thing. ISO for your VMs on Moodle. Okay, download it. Mount it. Mount it in each VM. And run the script. For a few small but important updates. Okay. As I put it in Moodle, there's going to be a new version going on the TinyNet site next week for the base and for the config ISO. Basically the same as what's there with important changes. Okay. You can only use one CD at a time. So yeah, you need to remove whatever's there and run the new one. Do I have that? Which directory do I have that in here? There it is. I've got a copy already. I put it on a different virtual machine, but I can just mount it here in Windows. I think that's the one I want to eject. Want this one? Yeah. All right. Hang on just 1 second. All right. All there is there is a fix. Oh, right. I can do that. Dan, just give me 1 minute. All right. Fixconfig.sh. All right. What it does is it puts in a new log rotate, set of log rotate commands for syslog to keep your log files smaller. All right. Adds that showparms.sh plus a few other scripts into the user local bin. All right. And it changes 2 other files. Okay. Changes 2 other files to make them a little bit nicer. All right. So there's only 6 or 8 changes here. It'll take about 2 seconds. All right. On Moodle, Hang on a minute. Where did we put it? I bet. There it is. There we go. I think that's the best way to get it. You just grab it off Moodle from the assignment folder. All right. Also, while you're there, project has been project resources document has been updated. So while you're there, grab a new copy of that one. Okay. Really, you don't. After the set. Really, you don't need any ISO after the set role configuration is finished, because that's all there is on the MyTyConf, all right? And so you just run that one once, and if it's there in the drive, then it doesn't hurt anything, all right? Just like the patch ISO, you only need to run it once, and if you leave it there or eject it, it doesn't really bother anything. Due date for the assignment part 2? Ooh, end of the semester. Hey, wait a minute, where'd it go? Yeah, this general. Last week of the semester, end of the week of the 13th of December. Okay, so yeah, there's still plenty of time. This part is kind of more relaxed, but there's also more decisions to make and some new ways to apply things. And so it's not the kind of crush time like we had in the first part of the semester. A bit less time pressure, all right? But you can do these anytime you feel like it, all right? But as we are today, we're going over some important concepts, all right, that we need to apply when we're making these enhancements. Okay? All right, so, right, the patch. Forgot about the patches, and I forgot to run it on my virtual machine here. All right. But I think hang on a minute, let me just look back here for one moment. All right, I think as long as we have, yeah, I forgot to put that backslash E in there. I tell you, the syntax for this is so weird and horrible. You really want to try to take advantage of your shell script. All right, and that show palms one is on the patch CD. And so let's just let's stop there. All right. This goes on a little bit farther again to other techniques that we can find applications, right, of this kind of redirection and shell scripting. Okay, so this is the thing. There's just so much that we can do. Right? We have to stop it at some point and relax a little bit and decide where we are. But there's a lot of great things on the TinyNet site that actually we don't have a chance to look at because we don't have enough time. I'm going to stop recording.